Example 8.10, the population mean weight of newborn babies for a western suburb is 7.4 pounds. Okay, so far the first sentence just tells you what the population mean is. It gives you the value for mu. Standard deviation, 0.8 pounds. So this is giving you the value for sigma. Then it says, what is the probability that a sample of 64 newborns selected at random will have a mean weight greater than 7.5 pounds? So the reason that you can see that this is a sampling distribution question and not a simple probability question from Chapter 7 is because it's referring to a sample size, 64, and it's asking about the probability of a mean, not the probability of a single value. Okay, a Chapter 7 question could say, what's the probability that a newborn selected at random weighs greater than 7.5 pounds? That could be a Chapter 7 question, and the reason why it's different here is because we're referring to a sample and the sample mean. So we need to identify the mean of the sampling distribution, mu sub x bar. Since it's always equal to the mean of the population, mu sub x bar is 7.4 pounds. Mu sub x bar, the mean of all the possible sample means, is 7.4 pounds. We need the standard error of the sampling distribution. So we're going to use our formula. Sigma subscript x bar, the standard deviation of the sampling distribution, which is known as the standard error, equals the standard deviation of the population, 0.8, divided by the square root of the sample size, 64. So 0.8 divided by the square root of 64, and that gives us 0.1. And if you're having trouble doing that on the calculator, I'll just review that real quick. 0.8 divided by second x squared. This is where the square root key is, right here. You have to use second and then x squared. And the size of our sample is 64. And you hit enter. 0.1. Okay, so with those two values, 7.4 for the mean of the sampling distribution and 0.1 for the standard error of the sampling distribution, now we can answer the probability question using normal CDF. So let's look at a picture. In the center, we label the mean and the standard error, 7.4 and 0.1. The x bar is the sample mean that the question is making mention of. The question asks us find the probability that the sample mean is greater than 7.5. So x bar is 7.5, which is somewhere on the right side of 7.4. And greater than 7.5 indicates the proportion of area shaded to the right of 7.5. So we put 7.5 on the horizontal axis to represent that value for x bar. And we shade the area all the way to positive infinity for the probability of selecting a sample mean greater than 7.5 pounds. So we're going to use normal CDF because that's what we do when we need to find probabilities for the normal distribution. The lower value is 7.5 and the upper positive infinity. The mean is 7.4 and the standard deviation is 0.1. Standard deviation of the sampling distribution is 0.1. So we go to our calculator, put in those four inputs, and we should get 0.1587. So I'll just do it real quick and show you. Second, DISTR. The lower is 7.5. The upper is 100,000. The mean is 7.4. And the standard deviation is 0.1. Notice that as far as steps involved to answer this probability question, there's no more work than a Chapter 7 question, except when finding the standard error. You have to make sure you're not using the standard deviation provided by the problem, that you're actually using the standard error that you calculated with the standard error formula. Other than that, there's no more work in trying to answer this question. So we get 0.1587. Okay, the population of all ages of U.S. college students is skewed to the right with a mean of 27.4 years and a standard deviation of 5.8 years. Determine the probability that a random sample of 49 college students selected from the population will have a sample mean age within 1 year of the population mean age. Again, we see that word within. So we have to do a little bit of work here. Now, we're told that the population of college students is skewed to the right. So it's not a normal distribution, in which case you wouldn't be able to use normal CDF on that population. However, when you poll that population and you use a sample that's greater than 30, you know that your sampling distribution is going to be normally distributed. You know your sampling distribution will be a bell curve because N49 is greater than 30. Now, since it will be a bell curve, a normal distribution, you have access to normal CDF. So we can answer this question with normal CDF. The mean of the sampling distribution is the same as the mean of the population. So you're going to use the correct symbol, mu sub x bar, and it equals 27.4. The standard error of the sampling distribution is the standard deviation divided by the square root of n. 5.8 is the standard deviation of the population. The square root of n is the square root of 49. Okay, because our sample is of size 49. So when we read these problems, we have to note what each of the numbers represent. Mean of 27.4 tells us that population mean mu is 27.4. Standard deviation 5.8 means sigma is 5.8. Random sample of 49 college students tells us that little n is 49. Okay, so calculating the standard error, you have 5.8 divided by the square root of 49, which should come out to 0.8286. So 5.8 divided by the square root of 49. 5.8 divided by the square root of 49. 0.8286. Okay. Okay, so to find the answer to this question, the probability, we need to find the sample ages that are 1 year less than the population mean and 1 year greater than the population mean. Because within 1 year means -1 to +1. So we're going to take 27.4 and subtract 1, get 26.4. Then we're going to take 27.4 and add 1, we get 28.4. So we have to find the probability that the sample mean falls between 26.4 and 28.4. So we're calculating the area between these two sample ages. So we label our curve, make a bell curve, and in the center you're going to label the mean of your sampling distribution, 27.4, and the standard error, 0.8286. 27.4 on the -1 on the left side, we have a sample mean x bar of 26.4. And then on the right side, we have a sample mean x bar of 28.4. The probability that a sample mean will be within 1 year of the population mean age is all of the area in between those two sample means, 26.4 and 28.4. So we find the area between these two sample means by using normal CDF. So our lower is 26.4, our upper is 28.4, our mean of the sampling distribution is 27.4, our standard error is 0.8286, and let's just demonstrate it. Second, DISTR, normal CDF, the lower 26.4, the upper 28.4, the mean 27.4, and the standard error is 0.8286. .7725 when rounded to 4 decimal places, 0.7725. So the probability that a sample age lies, or the sample mean lies within 1 year of the population mean age, is 0.7725.